All right, welcome back. So problem 9, this one I can use synthetic division because what I am dividing by is x plus minus a number. So since I'm using x plus 3, I can use my synthetic division. So again, when I'm dividing, I want to make sure I have all my x's. I do. So I'll just put their coefficients, the numbers in front of the x's, 1, 7, and 12. And remember, what you're dividing by, you always do the opposite. So we'll put a -3. And you start by taking the first number, dropping it, and then 1 and -3 is -3. Add them up. That's 4. 4 and -3 is -12. Add them up, and I get 0. So in division, this is the remainder. This is a constant. This is x. Since there is no remainder, I can just write my answer as 1x or x plus 4. Had there been a remainder, then I would have said plus my remainder, which I'll go ahead and show you, even though I wouldn't normally put this there, over what I divided by. So x plus 3. So again, we're not dividing just to divide. We are checking to see if what we're dividing by is a factor. So in this, excuse me, in number 4, when I was dividing by, x squared minus 4, I was checking to see if that was a factor, and it is a factor because I get no remainder, or my remainder is 0. And in number 9, I'm checking to see if x plus 3 is a factor of x squared plus 7x plus 12, and it is, again, because I get no remainder. And so technically, the two factors that make up x squared plus 7x plus 12 are x plus 4 and x plus 3. All right, moving along. So 10 is another division problem, just more practicing long division. So let's go ahead and set it up. Go through and add the opposite. Whoops. All right, so I'm going to add the opposite and add the opposite. So in my first part, first set of parentheses, I do have all my x's, so I can just put those in the box. 3x to the 4th. Again, I'm going to put a -1 in front of that x cubed, 8x squared, 5x, and 3. And then when I'm dividing by, I also have all my x's, and I'm going to put 1's in front of them. So 1x squared, -1x, and 3. And now I'm going to start by asking, what can I multiply 1x squared by to make it 3x to the 4th? So to get from 1 to 3, I need a 3, and from x squared to x to the 4th, I need an x squared. So I will be multiplying by 3x squared. I'm going to draw my 3 branches to each number here. And again, technically, this is a neighbor meets a neighbor situation. So 3x squared to 1x squared is 3x to the 4th. 3x squared to -1x is -3x cubed, and 3x squared to 3 is 9x squared. So I'm supposed to subtract all of it. All of it is why I have the parentheses, and I'm going to go through now and do adding the opposites. So add opposite, opposite, opposite. And when I add this column, they cancel out. When I add this column, I get 2x cubed. Add the next column, I get -1x squared, and then I'll bring everything down and start the whole process over again. So what do I have to multiply 1x squared by to make it become 2x cubed? So to get from 1 to 2, I need a 2, and x squared to x cubed, I need an x. So I will multiply by 2x. 2x now is going to follow these 3 little branches here. Okay, so 2x to 1x squared, 2x cubed, 2x to -2x, or I'm sorry, to -1x is -2x squared, and 2x to 3 is 6x. Subtract it all. Go through if you like to add the opposite, so add the opposite, the opposite, and the opposite. Again, this set should cancel out. When I add this column, I get 1x squared. Add the next column, I get -1x, and bring the 3 down. And now I'm going to start the whole thing over again. So what do I have to multiply 1x squared by to get to 1x squared? That's just a 1. 1 will follow the 3 branches that have been highlighted. So 1 to 1x squared is 1x squared. 1 to -1x is -1x, and 1 to that 3 is 3. Subtract it all. Again, if you'd like to add the opposite, you can. So I'm going to add and do the opposite, and the opposite, and everything is going to cancel out again. So this time I'm just going to write the answer the way it should be written. I won't put in the remainder. So since there is no remainder, it's just 3x squared plus 2x plus 1. That is the answer to the division problem. And it also means that x squared plus -x plus 3, you know what I was dividing by, that this is a factor. Okay? All right, next one. Here I can do synthetic division because I'm dividing by x minus 2. So when I look at what's going to go in the box, I am missing an x, so I'll put a placeholder. So here's a 1 for the x cubed. There's x squared. There's my placeholder for x and -4. And again, what I'm dividing by, I will take the opposite of. So I'm going to start, bring down the 1, start multiplying. 1 times 2 is 2. Add them up, I get 0. 0 times 2 is 0. Add them up. 0 times 2 is 0. And I get -4. So this time I do have a remainder. This is the constant. This is x, and this is x squared. So here my answer is, I won't put any of those zeros. It's x squared. And now my remainder, that's the numerator of my fraction and what I divided by. So was x minus 2 a factor of the original problem? No, it wasn't, because I did get a remainder. All right, next set we are solving. So here you should expect imaginary numbers and real numbers. I will always attempt to factor everything, but then if I can't, then I shall do the rational root theorem thing. Okay, so the first thing I'm going to try on number 12 is there a GCF? There is. I'm going to take a 2 out of everything. Okay, so dividing everything by 2. And then with what's left, I'm going to, since there are 4 terms, do the grouping method. And now I'm going to look for a GCF in this set. And I can take out an x squared, and then I'm left with x plus 6. So that means when I go to factor this next set, I need a matching set of x plus 6. And I'll want to know what times x gave me this -4x here. That would be a -4. So joining the 2 is the x plus 6 and x squared minus 4. And what I do notice here is that x squared minus 4 is the difference of squares, so I'm going to factor that a little bit further. So 2 will stay the same, x plus 6 stays the same, but x squared minus 4 can turn into x plus 2 and x minus 2. So my answers here are x equals -6, x equals -2, and x equals 2. I should have 3 answers according to this little exponent here, and I do, and they all just happen to be real numbers. So here is my, oh, that didn't turn out very well. That is my final answer. All right, 13. First thing I'm going to look for is for factoring. Is there a GCF? There's not. With 2 terms, though, I'm going to look for a difference of squares. And this is, I can take the square root of this, which is 2x squared, the square root of that, which is 9. And now my factors are 2x squared plus 9 and 2x squared minus 9. I can't factor anymore, so I'm ready to set these equal to 0 and solve. So let's start with this one. So first I'm going to move the 9 over by subtracting. So it gives me -9, and then I'm going to divide by 2. So that's, I'll go ahead and put the decimal, -4.5. So at this point, remember we did switch the setting on our calculator to work with real numbers. So I'm going to be taking, even though you can't see it, the square root of -4.5. And I shall be getting 2 answers, the plus or minus, and when I round it to the nearest hundredths, I get 2.12i. So there are 2 answers, they just happen to be imaginary. And now I'll take the other one, the 2x squared minus 9 equals 0, and set that and solve for that one. So first I'm going to add 9, and then I'm going to divide by 2, and now I'll take the square root of just 4.5, so I'll get plus or minus for the square root and a regular 2.12. So I have 4 answers here, because that's how many I'm supposed to have. 2 are imaginary and 2 are real. All right, 14, I'm going to look for a GCF. I don't see one, but with 3 terms, I'm going to start with the x.